So yeah, hello everyone. My name is Amr Kilic, and today I'm going to present our attempt in Qur'an QA 2020. And our paper is called Creating Better Faithful Data Splits for Low-Resource Question Answering Scenarios. And it was done under the supervision of Dr. Walid Magdi at the University of Edinburgh. So first, what makes actually QRCD more special? If we compare it to Squad, which is a popular machine comprehension question answering dataset for English. So Squad has 100K questions for 23K unique paragraphs or passages, which implies that the average number of questions per passage is about 4.31. And if we look at QRCD, more specifically on the training split, we'll find that the questions are just 710 for 468 unique passages, which means that the average number of questions per passage is just 1.51. So clearly QRCD has smaller size, but also it has less number of questions per passage, which is a problem for large pre-trained models, because if they don't see different values or different questions for the same passage, maybe that's one more opportunity for them to overfit actually an answer for a specific passage. For the model fine-tuning, we didn't really use a special model, so we just fine-tuned different BERT models. So we feed the passage, the question, and just ask the BERT model to predict the start and end span from this passage. And more specifically, we tried 4 slide variations of the fine-tuning setup. So the first 2 are just fine-tuning different BERT models, which are Camel BERT pre-trained on classical Arabic and Camel BERT pre-trained on modern standard Arabic. And then we try to feed or augment the model with more information, like giving it information about named entities or stemming the text using Farasa before actually feeding it to the model. But in the end, we just went with vanilla fine-tuning Camel BERT classical Arabic without ensembling as our main model for this shared task. So once we fine-tuned the models, we had a problem that the PRR scores weren't actually stable. So we tried doing some error analysis. So the first part was to actually try to categorize the questions. So we use the interrogative articles like meta and aina and hala and so on as a proxy for the kind of reasoning actually that needs to be done by the model to answer such questions. And if we look at the distribution of the interrogative articles within the train and development datasets, we will find that actually articles like hal and maza are more represented in the development dataset than the other articles. And they also have good representation within the training dataset. And we also noticed that for such articles, there are questions having these articles achieve high PRR scores, which might indicate that there is a good generalization from the model. But actually, we think that this wasn't really the case. So over here, we are showing questions in the training dataset and another question in the development dataset that actually shares the same passage and shares the same answer. And if we look at the questions, we realize that they are actually paraphrases of each other. So if we say that the model is able to answer the question in the development datasets, maybe that's not actually generalization, and it's just generating this answer once it sees the passage, and it's not doing any kind of reasoning, which is a shame, I would say. So we decided to actually concatenate the training and development splits and try to resplit the data in a way that actually gives us splits that don't have such overlap, or we can say leakage, such that we can actually better understand how the models are working and comparing different architectures and models. So the process goes as follows. We first look at the passage for each question. If it's unique, then we see if the answer from this passage is found in any part of the training data. If that's the case, then we say there's yeah, sorry. I'll just go back once again. So first of all, if we see if the passage is unique or not. If not, then it's repeated passage. And we see if for this repeated passage, it has actually a repeated answer. If that's the case, then this is the first bucket, which is more of a leakage, because the passage is not unique, and also the answer is repeated with different questions or different triples. If the answer is unique, then we say this is still in domain because the passage is being used more and more, but the answer is actually unique, so there is no leakage. If the passage is unique, then this means that maybe the question will be harder. So we decided to also split it into two types. One where actually questions are, the question for this passage is also unique, and the other one which is a question that is being seen in the training data, but for different passages from this one. And if we look at the difficulty of generalization for these four new types of data sets, for the first one, we see that it has a repeated passage and also a repeated answer, which means that if the model just memorizes that this is the answer for this passage, it will be able actually to solve different variants of questions within this data set. So yeah, this clearly doesn't really measure the generalization. For the second one, which has a unique passage, but a repeated question, we assume that maybe since the question is repeated, so possibly the answer will also be similar to other answers seen for other questions, and which implies there is still a possibility of memorization. For the third one, it's a unique passage and a unique question. So these are clearly unseen questions for passages that are unseen as well. So we can use them to test the true generalization of the model. And for the last type, it's a repeated passage, but a unique question, which means that the question is new to the model. So if the model actually memorized an answer for this repeated passage, then it will actually fail badly for such questions because it's a unique question, which implies most probably it's it needs completely different reasoning and it needs a completely different answer. So we would say this is the most challenging data set for the model. And for generating splits, we used random splits for the second and fourth data sets. We kept only one instance from triples having repeated passage answers pairs within the first data set. And we used actually the third one, which has unique answers and unique passages as a development set only, and we didn't really use it in training. And if we look at the PRR scores achieved on the new development splits, so we trained the model or fine-tuned the model on a concatenation of the training splits from the four data sets, and then we evaluate on the development split of each data set. So the scores on the development split of the first data set is 0.8. For the second one, it's 0.5. Actually, it's the fourth, but I mean the second from the difficulty of generalization. For the third one, which has unique passages and unique questions, it's 0.4. And for the second one, or the hardest one, which uses unique passages, repeated passages, but unique questions, the PRR scores are the least, which implies that if the model actually is memorizing answers for this repeated questions, then it can't actually solve new questions that aren't seen in the training data, which implies it's actually memorizing and overfitting the data. And if we look at the evaluation of the different models on the third split, which is only used for development, we found that actually all the kind of attempts we were trying to improve the performance of the model weren't actually doing any kind of improvement. So we ended up just using the vanilla fine-tuning of Camel-BERT pre-trained on classical Arabic as our main model. And lastly, if we compare between the results on the hidden test set to the PRR scores achieved on this third data set, which we call out of domain and hard, we'll find that actually there is kind of a proximity between the scores. We can't really generalize and say that they are perfectly aligned, but at least we don't see much drop or much difference between the PRR scores we get on the third data set and the PRR scores we get on the test set. So this kind of shows that by actually trying to avoid the leakage between the training and development data sets, we can actually achieve better understanding of how the models really behaves and don't get inflated scores on development sets that changes dramatically once we go to evaluate on the unseen test set. So for reflections and going further, we would say that maybe trying to minimize the leakage between training and development splits might be better for fairly comparing between different models and to actually get an understanding of how adding or changing hyperparameters or even architectures affects the results. We also say that we needed to use models pre-trained on modern standard Arabic, since it's crucial for questions. For example, in this question, هل أشار القرآن إلى نقص الأكسجين في المرتفعات? So clearly it uses the term oxygen or oxygen, which is not a term in classical Arabic. So for a model actually to be able to understand or to reason about such question, maybe it needs to have kind of an exposure to modern standard Arabic text. And we claim that if the way further is to create actually larger data sets that covers more topics or more question types, so maybe we can try to have more than one non-trivial question for each unique passage, such that the model doesn't just memorize an answer for each unique passage and then it's not doing much reasoning, but we acknowledge that this is actually easier said than done. And maybe when we have different passages, it's not actually trivial to find different questions that still make sense for each passage. And lastly, we think that it might be actually better to avoid questions that can have multiple interpretations, like متى يحل الإسلام دم الشخص, or when, I'm not sure if I can properly translate it, but when does kind of Islam approves to kill someone? And we think that actually such questions are not like factoid questions. They still have different interpretations, and given that actually the current models are just black boxes, so we can't really understand why the model is behaving in a specific way. So maybe it's actually better to avoid such questions and just focus on factoid questions that clearly have answers that will have less disagreement. So that's it for me. Thank you very much for listening, and I'll be happy to answer your questions.
Thank you very much, Amr, and very nice analysis of the data set. We have a question on the chat from Muhammad. He says, why do you think MSA pre-trained models performed worse?
So we didn't really try with different models. It was just Camel-BERT pre-trained on modern standard Arabic. Yeah, if I just get back.
Yes, as for us, we observed the opposite. Modern standard Arabic performed better for my case. That's why I'm asking. But I didn't try Camel-BERT. Do you hear me, Faris?
Yeah, I can hear you. Yeah. So, yeah, I'm sorry, I'm not really sure if I have like a clear answer for that. Maybe using different models kind of changes the results you get. I'm not sure about the model you have used, but I only used Camel-BERT. But yeah, I can give you different interpretations just based on my results. So I can't really say I had an intuition that classical Arabic model would perform better than the modern standard one. But yeah, that was the case for me. And yeah, I can see the point that for specific questions, using modern standard Arabic might be better. But yeah, it wasn't the case based on my fine-tuned models, which have lots of hyperparameters. So maybe yeah, I needed to fine-tune them better.
Okay, thanks, Sam. There is another question on the chat. You can, I think, read and reply to the chat from Professor Eric. Okay, thanks, Sam. Next, Iman.